All right. Welcome to the once every 2 months Lean community meeting. It's great to be back. Recording just got turned on, and we have pretty healthy attendance. I was joking with Kevin when he showed up that it's been a very quiet 2 months since the last meeting, so I don't know what we'll have to talk about. One thing that I would like to hear about, if there's anyone who attended or was involved in, was this reviewer boot camp that happened recently. If anyone wanted to report on their experiences, lessons, interesting anecdotes, that'd be great. Was there anyone who was there or involved with that that's on the call?
Sorry, I missed the question. I was trying to get Patrick set up with Teams.
Oh, good. I'm trying to figure out if there's anyone on the call who was involved with the boot camp, the reviewer boot camp.
Oh, the reviewer boot camp.
Yes.
Yeah, I heard good things about it.
Yeah, people seem pretty happy. I heard some feedback, but it'd be nice to have someone talk about their experience, if anyone had that experience.
Yeah, my experience from sending my PhD student Edison there was that he couldn't get a visa for Sweden. So.
Oh, really?
Yeah. He needed a Schengen visa at last minute, and it didn't happen.
Well, I will see if anyone else shows up in the interim and try again later in the call. I have to admit, I did not plan much in terms of structured discussion for this meeting. So maybe it's best to just toss it to the floor and see if anyone has anything they want to talk about.
I've nearly bumped FLT to version 4.29.
That is a bear to tackle, yes.
In retrospect, I think I made a mistake. The community said, "Oh, don't do any bumping. Don't, just leave it. And then, like, we'll sort out all this backward transparency stuff." I think that was the wrong thing to do in retrospect, because there was a huge valuation refactor that broke a lot of FLT. And so we had to deal with sort of two massive problems all in one go, and you didn't even know what caused what problem. So I think I should have ignored the community and just kept bumping once a week, which is what we were doing beforehand. And just globally set backwards transparency to false in the, and then just dealt with the valuation issues as they arose. So that's we live and learn, but somehow 6 weeks of not bumping after two major disruptive changes was, as I say, we're still getting over it.
Well, it does remind me, I think I saw Marcelo post something called Hopscotch, which is supposed to assist with the bump itself. And I thought Marcelo was here. Yes.
Hello.
Hi.
Yeah.
Good to meet you.
Yeah, good to meet you too. How are you?
Great. So how do I bump my we've still got about 8 files to go. We've changed 60 files. I mean, this is a huge disruptive change. We fixed 60 files, but there's still 8 to go, and one is non-trivial because of the valuation bump, not because of backward transparency.
Yeah, this one, I mean, 429 was pretty disruptive, I think, right? There was a bunch of RCs as well. Or is it 428 you're talking about? Anyways, it doesn't matter.
Ironically, the backward transparency stuff, we've dealt with most of it. By accruing technical debt that we'll deal with later. But independently of that, we had a change in the definition of valuation, basically, which has had huge disruptive consequences for this and the class field theory repository. Class field theory repository, we've done it. We finally bumped it. And that, again, that was one of my PhD students did it. It was a huge effort, but it's been done. But that's last year, and we're still struggling through it. But, we'll do it. But, I had a 2-hour meeting with a postdoc this morning. We'll be plowed through some more stuff. And
So the tooling that I'm building with. So there are two things. One is this tool that I posted about already. So it's kind of ready to use, and any feedback would be great. So the point is to aid this bumping, and so it's not going to be very helpful with these like toolchain bumps, which are like a single Mathlib commit that bump the toolchain and maybe breaks a bunch of stuff in your project because now you need to bump the toolchain.
Actually, it's just one. It's not that. It's actually another PR that's our main problem now.
So the point of the tool is to go like commit by commit of Mathlib and updating your project like very granularly, and it's actually not going linearly, but like doing like a binary search, right? So you point the tool to your project and to a target Mathlib revision that you want to get to, and it'll just like bisect and find the first Mathlib commit that broke your project, right?
Okay.
So
no, I know exactly which commit broke the project.
Yeah, well, if you're there, but the point is that like at some point you're like, oh, I want to bump my project. There was like 2,000 Mathlib commits, and I don't know when the conflict will be. And you can go step by step and be like, oh, you go click what happened in Mathlib, and oh, this is trivial to fix in one go, and then you continue on, and then you can update in a better way.
That's good to know. Thank you.
Yeah, so that's one thing, and the other thing. So I still hadn't posted about this. I talked about this with some people because some maintainers of like projects like actually FLT is in this, but I can link to it. It's we want to continually run this tool for downstreams of Mathlib, so we can see when downstreams are broken and alert, and like people can do things about it if they want to, or just know where the first break was when they want to bump, right? So part of it's like the sort of service side of this tool, trying to maintain like a dashboard or some service for downstream to see, okay, I want to bump now, like where I'm at, like should I run the tool locally, but you can know exactly where it broke. So I'll link to this in the chat. Still haven't like made this public because I'm working on some stuff, but you can see how the thing looks. It's basically like a little. So you can FLT is there. You can filter in that little box. So you can basically see where the thing is, where the lake file of the project is right now, how old that particular version is with respect to like today or the last time this sort of thing ran, which should run daily now. And then I don't know if people are looking at it, but basically tells you if you can bump to the latest Mathlib, and if you can't, then what's the most you could, right? And the first thing that broke. So yeah, I mean, right now, if people want to use this, let me know if people want to onboard to this. I'm going to publish something in probably next week, but it's ready for more stuff to onboard. And yeah, I mean, right now maybe everybody will be very stale, but if projects stabilize, this should be like a good way to signal, okay, we just broke everyone with this commit, or like if somebody's interested in alerts, that can also happen. So sorry, the repo is still private. I can make it public now, actually, now that I shared it. And I had called this hopscotch reports first, but I thought that was kind of too esoteric, so I changed the name. So I didn't want to make it public before then. But yeah, I'll do that now. Yeah, so basically, sorry, I've been talking for a little bit, but the whole point, so there's maybe 2 points to this. One is to have some sort of health signal for the dependence of Mathlib, but also providing some mechanisms for bumping assistance in a way, right? Like, and try to keep everybody up to date as much as we can.
Is there any way to kind of collect commits that go along the bumps or something so that you don't have to relearn the same lessons downstream projects over and over again?
Yeah, so one of my particular goals, but this is in a way, it depends on the style of work of every maintainer of a downstream, right? Maybe some people want to sort of, and that's one thing that I don't really like that happens now, is that like when there are these adaptation commits, everything is squashed together and you can't really see what went on. And so the tool, if you run it locally, it actually won't let you continue unless you commit the changes that fixed the project, right? So trying to enforce this granularity, right? And yeah, be like, okay, let's fix one thing at a time. And this, in the ideal dream world of infinite resource and time, then we can automate some of these fixes maybe in the tool itself or with some other tools, right? So maybe you can say, okay, you commit to Mathlib and you're like, I know this commit will break everyone that's using this declaration, right? And then you can maybe fix it automatically, right? And so having people being used to fixing things one thing at a time makes maybe that transition easier later to like provide like atomic fixes to things that are kind of standard, right? Standard breaks, which you all know about more than me. Just a bunch of upstreaming things, renaming things, or things that we can know, or automated refactors. But definitely, but of course that depends on every project. Like if you want to squash everything or like push it commit by commit. The point of having this dashboard and alerts and all of that is that in the ideal world, everybody would fix it immediately, right? And you have one commit per break. You break, Mathlib pushes, it breaks your stuff. You get an alert. You're like, oh, okay, I'll fix it now. You do it, and then everybody's healthy and green, and it's gamified because I added colors to the dashboard, so everybody wants to stay green. Stay green, people. I don't know, but of course, people, some of these projects are in like maintenance mode. It depends a lot on the downstream, and I want to be very flexible to different styles of maintaining a downstream, because there is diversity, and also we want to keep everybody happy, I guess. But that's a very point. So on that same note, of course, if people have ideas of like how to keep projects healthier or testing, a lot of this thing is kind of starting. There are some stuff that I want to add to, like more flexible, like pre and post build stuff that people might do locally, right? Like now it's like just update plus build, but I don't know, like running a test after this thing to just add on top of these sort of what it means to test for a Mathlib bump, right? So all those sort of things are probably things that are that we need to extend the system with. But for now it's just building.
How do you get on the list of projects?
Oh, I mean, Johan kind of gave me a list, and then I bug people saying, "Hey, are you interested in trying this?" I was talking with some of these projects maintainers just to gather some very early feedback. But as you saw, I pushed the tool thing already, and I was finishing this report before publishing this one, but it was already kind of there. So yeah.
So they should just reach out to you, I guess, if they want to.
Yeah.
Okay.
Yeah, I started with a small list, and then give me a bunch, so you can see there's a bunch that are his and are maintained by him.
Very cool. David has a question.
Part question, part suggestion, I guess. I read earlier today about somebody creating a library of, I think it was called something like Just About True or something, specifically designed for
merely true,
whatever it was called, for AI slop formalizations, with an incredibly strict rule that they would bump Mathlib regularly, and anything that broke would just be deleted from the archive. And it would be interesting to sort of connect this in to the downstream reports thing, because if somehow one feels that if anything will break under the slightest change, it will probably be that.
It's definitely add merely true.
Merely true, yeah, that was the word.
I think it's GitHub user merely true.
I think at the moment there's only like one or two small proofs in there, but it seems likely that if it catches on at all, it will grow massively and explosively and be full of very, very brittle code.
let's see, I'll put the link. I think that's the correct one in the chat.
Yeah, that was the one I meant.
You know, I haven't actually looked through the workflows in it. I know what people said it does, but I haven't sanity checked what it's actually doing yet. Because then you said, I think there'll be a lot of demand, and also with demand comes a very individualized requests about, oh, this project should be treated like this, and this project should be treated like that, and such and such.
Yeah, well, it's clearly a major problem at the moment, how to handle people who have their pet formalization project, which is 99% AI generated, and they're cross that Mathlib won't take it. So if these things end up in merely true, then it might be the best solution for all concerned. Incidentally, does anybody know who's running this merely true project?
Yeah.
Well, as Kevin said, the username is merely true.
I mean, isn't it public? It's surely Kim Morrison.
Yeah.
I mean, Kim's the one who's pushing it.
Okay.
Well, it seems like Kim made it, but doesn't want to maintain it. It's just it automatically merges PRs.
Who wants to maintain
AI is
it?
going to
Yeah.
maintain it. Right?
Yeah.
I guess the whole point is that it isn't maintained. It's an interesting experiment, certainly.
I like it when my kids clean up after themselves.
Yeah, but I mean, if we can train the AI to do that, I mean, this
Exactly.
is what can you train it to do, right?
All right. Well, it'll be interesting to see how that goes.
Yeah, there's no manual review, as Marcelo points out. There's no manual review, but on the other hand, if Marcelo is flagging when merely true breaks, then perhaps before Kim just deletes the code that's broken, the AI can have a chance to be alerted to the fact that it's broken and look at the Mathlib commit that broke it and fix it. And it just sounds like a very AI-ish thing.
I don't know. I got to wonder how Zenodo is handling the increased traffic.
The guy that worked at Archives I had dinner with the other day told me that Zenodo is strongly considering just pulling out of this whole giveaway DOI Safari thing. Apparently it cost them 10 cents per DOI.
Oh my.
I know.
It's like, can we have Zenodo or can we have another collider? So let me, since we're a little bit in, and there's a bit of a lull, let me try my question again. Did anyone attend the reviewer boot camp or have stories that they can relay? I think that's a valuable thing, is try and grow the community, grow the expertise space. All right. Well, I'll try again later.
On that,
I agree with you. Sorry, David.
Yeah.
On that topic of reviewers, maybe this is, I'm not sure if this is the right forum to bring that up, but since the topic's been raised and nobody else is saying much, is there any plans to maybe make the assigning of PR reviewers a bit more targeted? At the moment, PR reviews are shared out according to very, very broad topic areas. And if those could be made a little more focused, it would make it much more likely that PRs ended up with reviewers who could actually review them.
I think people are aware of this. I don't know of precise plans. I mean, Brian's probably the person to ask and ping about any precise plans that exist. Do you have suggestions as to how to go about doing that?
You could look at who's touched a file before
You know,
and kind of give some weight to that.
Sure, well, GitHub already does that, doesn't it? And suggests reviewers, and the suggestions are sometimes completely wrong, but occasionally helpful. I was thinking more along the lines of more specific topic area tags rather than the brush ones we currently have.
I mean, the Zulip, or sorry, the GitHub labels, I don't know how far you scale out if you try and make a, MSC code classification within that. I think that's a good idea. But I worry that the labeling system is not the most robust way to handle a whole lot of different topics in and of itself. So I'd be very interested to hear about any other ideas to manage that state.
We've got suggestion in the chat about, or observation in the chat that there's now nesting of topic labels from, sorry, I don't know how to pronounce this, Sneer. I didn't know that existed. I'm not sure if it's been implemented yet in any way.
That's good.
I mean, if there were a tag for modular forms, I would absolutely welcome being the default reviewer for that. But at the moment, it's just number theory, and number theory is a very broad area.
Yeah. I mean, another mechanism that people use are code owners for GitHub projects. I think that's been discussed somewhat in the past, but maybe not seriously fleshed out as a way to go.
I think there's only a few small parts of Mathlib where you'd be able to identify an obvious owner.
Yeah. That's true.
I mean, obviously, if you have something about C-star algebras, we'll know who to send it to. But if you have something about, I don't know, continuous maps, then it could be just about anybody. Here's something more in the chat.
Yeah. A couple of PRs that look relevant. Okay. So one is about trying not to have redundancy in the labeling. And let's see.
David, how are we going to get Hilbert modular forms? I might need them for Fermat. And I don't know the definition. Because,
What do you, depends what you want the definition to be, surely.
yeah, yes, yeah. I want the idyllic version, so there's a class group issue. I don't quite know how to go about. There's a sort of a big design decision to make at the very beginning. There's functions on products and copies of the upper half plane, modulate some random discrete group, and then change the group. Or do I do everything idyllically from the get-go? Anyway.
I strongly believe that doing Hilbert modular forms in any way other than identically is going to be very miserable.
That's an interesting observation. And identically is, of course, what I want. So. Why didn't you do classical modular forms identically?
Because of the well-known phenomenon that Q has narrow class number one.
Except for Y, yeah.
I mean, I don't want to bore everybody else here with me and
Theorem
Kevin
of Euclid.
forms, but for what it's worth, we actually have in the definitions set up now, so you could do some Hilbert modular forms via Shimura curves, upper half plane stuff we already have.
That's great. I trusted you to be sufficiently sensible, and it's great to hear that you were.
We created a great deal of unnecessary pain for ourselves in the process. I don't know if it was so sensible.
Well,
But this is number theorists talking number theory, so let's not bore the rest of the group here.
So one thing I am curious about is how Julian's experiment with his Python kernel implementation is going on the arena.
It's hard. So yeah, I haven't announced this. It's just something that we play with at the New York City meetup. But we've been trying to write a kernel implementation. At the same time, we've been trying to learn how to implement a kernel implementation, and probably not being vocal enough when we run into cases where we can't figure out what we're supposed to do from either the type theory book, which is great, from Chris, or reading Lean's real kernel.
is it
as
R.
of-
Piley?
I'm sorry?
Is
Yeah,
it on
that's
the
right.
list already?
Yeah.
It's R. Piley. Oh, you're so close.
Yeah, so you just noticed. So as of 2 weeks ago, I think we now pass all of the tutorial tests. So one cool thing that Joachim did, which definitely saved us a ton of time, is Joachim wrote like a tutorial for how to write a kernel. And you can sort of follow the tests one by one to learn about each of the features of Lean's type theory. It's not complete in the sense that what Kevin just noticed, or what you'll notice if you look at the kernel arena, is that we now pass all of those tests, and yet we're not even able to type check init prelude. So just type check like the first part of Lean's prelude, we fail. We fail for a couple of reasons. I think the first reason that I understand, and when I say understand, I'm using the word very loosely, is like you have to do special stuff to implement natural numbers in Lean, and I won't even try being more precise than that because I don't fully understand it yet. Otherwise, we would fix it. And we're unfolding things in a way that blows up. So Aaron Hill, who's also worked on it with me, understands it a bit better than I do, and I think we have our delta reduction implemented slightly incorrectly, and we're unfolding things incorrectly, or not taking into account the hints that we're supposed to be taking into account. Anyways, we pass all the tutorial tests. We don't yet pass init prelude, but then there's kind of a logical sequence. So after we type check that, then we try getting to the point where we type check all of init, and then eventually somewhere in between there is being able to type check stuff like Mathlib, and then beyond. So it's a lot. It's interesting. I'm learning stuff. We're learning stuff. Yeah, I don't know if that part answers your question in the sense that's where we are. It's a learning project. I do think we'll be able to get it finished at some point. AI helps, but in
You look very
ways.
close.
Yeah, we're very close, but very far. I think that there's a big gap, and again, I'm sure an expert will tell. Like, I think there's a very big gap between being able to type check init and being able to type check Mathlib. What I've heard from experts is that being able to type check init you can kind of do, even if you only sort of know what you're doing. But then being able to type check Mathlib seems to require optimizations very similar to what the real Lean implementation has. And if you don't do things in very similar ways, then you just, because Mathlib optimizes itself to basically type check using real Lean, if you're doing things in a different way than real Lean is, and you don't have the same kinds of representations, then you're unlikely to be performant enough to type check it. That could be total nonsense, so someone will correct me, especially if they're on this call, but that's where we are. I say AI is helpful because, like, it definitely has been the case that if you point Claude code at a test that fails and you do it in the right way, it will be able to modify the kernel that we've written to make it pass. But then you have to stare at it and decide whether what it just did makes any sense whatsoever. Like it certainly has in some cases just completely written nonsense just to pass the test that was failing. So you still have to understand stuff, unfortunately.
Yeah, I tried just a one shot at, told it to write a kernel implementation in Go, and then it said it did it. And I was like, okay, great. Now go type Mathlib. And then I couldn't SSH into my machine because it ate all my memory.
Yeah, I'm not surprised.
So I didn't look at any of the implementation. It was just sort of, what's going to happen if I open this box kind of thing.
I mean, one thing that it's at least slightly better at in this context is that sometimes when I'm very bored, I feel like adding random things just to see. Like I asked it to add syntax highlighting to the pretty printer. As far as I know, the real lean kernel doesn't do. Like, can you pretty print something with syntax highlighting when it type checks it? And it added it. So now when you print stuff with the type checker that I wrote, like that we wrote, it'll print terms syntax highlighted to the terminal. Is that useful? No, it's not useful at all. But it has colors. It's nice.
I like it. I think it's great.
Yeah.
The other thing I'd request is like better error logging from the actual kernel, so that I know when, oh, you switch these two universe levels and the whole world blows up. Actually, it's this particular branch of the logic where it's not checking the order of the universes correctly, as opposed to just like, oh, it's somewhere in the kernel. Go find it.
Yeah, so I'm all right. I was about to screen share something. I can't screen share. It looks like, but I'll paste the screen capture. So that also, I think AI has been helpful. It helped implement, like when a term fails, it added me like underlining when we pre-print the term, it underlines the part of the term that didn't type check, kind of like Rust-esque, which real lean doesn't need, because when you're sitting in an editor, the error appears on the line that you're working in. But in the console, when it's printing stuff out, now it tells me like the error is here, which is nice.
So while we're requesting features from Julian's new kernel, what I want is to be able to step through a kernel reduction and see each step. And I implemented this for Mario's kernel, but like it's stuck on version 4.4, and Mario's added so much since then. I don't know how to like update it. So
I have a tracer, which I haven't used other kernels, so I should use other ones so I see what they do. The tracer that we added will basically show you each of the steps in reduction during definitional equality checking.
Okay, maybe you already have what I want.
Maybe. So I can show you what that output, I'll paste what that output looks like to you. But the thing is, and again, since I'm not an expert, I don't know, it doesn't thread through each of the individual reduction, like which reductions does someone want to see in that output? So there's some that it will show you, but yeah, you'll tell me whether it's...
I mean, I just want to see like the whole term now, the whole term after the next step, the whole term after the next step.
Yeah, we have something like that. I'll show you what it looks like. Yeah.
Why doesn't the arena report speeds, even for the fraction of tests passed? I really like to see a speed number associated to your kernel, and I mean, I guess the always reject and the always decline aren't. They should be pretty fast.
So you want something beyond what the timer column shows? So that timer column, it won't show for mine because we can't type check Mathlib, but the timer column on that page. So for anyone who doesn't know what we're talking about, oh, okay, you pasted it already. But the timer column there is how long does the kernel take to type check Mathlib? It doesn't work because we can't type check Mathlib, but all the real kernels can, like all the correctly written kernels can. So they appear in that column.
But just what do you get to and how fast do you get to it, right? That'd be nice.
On a different benchmark. Sorry, maybe I misunderstood the idea. On a different benchmark, you're saying, or?
I just want to know, of the things you can type check, how fast do you do them in comparison to all the others?
I see.
Right.
I see. Like basically for all of the tests that you pass, like how does your speed compare to other ones?
Yes. I mean, it could be just average per module or something.
You're passing the tutorial. How long does it take to pass the tutorial?
Yeah. I hesitate, like, again, because I'm not an expert, Joachim asked me, like, hey, you're very fast on this benchmark. Do you understand why? And me and Aaron looked at each other and basically said, I'm very worried that we're missing something and that we're very fast because we're missing some architectural thing that we're not doing. And that's why we're very fast. So the thing with benchmarks that makes me uncomfortable as a software developer is that if you're not fully correct on everything, then comparing you to someone else on speed is somewhat meaningless. It's like, yeah, we're very fast. Like, you're missing the thing that, like, unless you're 100% correct, you being very, like, wonderful.
It's working really well for the AI companies, though.
Right. This is why I'm not an AI developer. Yeah.
Yeah. Don't pull out that thread as a mathematician.
But even so, it's just fun to see. It's just how fast, right?
Yeah. I mean, Joachim is super like, I don't know how he put this together so well and so fast. I feel like if we asked him for that, he'd be open to it.
He's just a generally awesome person.
Yeah.
It's just one of the phenomena of this community is, I mean, hopefully it will remain that way, but so there's that habit of attracting very smart people.
Mm-hmm.
It might not stay like that. You remember at the beginning of Math Overflow, there just seemed to be just a bunch of very smart people. And then somehow it got more and more polluted. So we got more, when people started posting homework problems, it was like game over. Like, wait a minute, I remember it was just a bunch of graduate students and postdocs in algebraic and differential geometry posting hard problems. And then what's all this stuff about sines and cosines? How does that happen? It sort of becomes the victim of its own success.
So we have a question in the chat. Miyahara asks about a RSS feed for recent commits of DocGen.
Oh, who was asking me if I wanted RSS feed for FLT? I think there is an RSS person. I can't remember who it is.
I mean, what I just usually do, maybe not RSS, but just follow the repository, I guess. I did this for the comparator one, just because there's either like the most mundane commits, which is like bump to whatever, or there's like, oh, here's an insane exploit. We probably should patch this. So it's fun to see those come across. But if you know.
Ah, okay, got it. It's Josh and Menican.
Yes, if there's consensus on what should be in the hash RSS, then please feel free to, either just.
Oh, okay. Oh, you mean in the Zulip one? I see.
Yes.
I thought this was a personal request. Okay, thank you.
Yeah, feel free to write to Yasha or me.
Okay. Hmm. I guess I'll try one last time. Any chance that anyone came to the boot camp has shown up in the interim? I don't think so from the numbers, but. I guess I won't go so far as to get a hallucinatory account from Gemini or something of how it went.
There should probably be a blog post, really.
Yeah, that's a great idea.
Because it was a new thing. This is the thing.
Yeah.
But when you try a new thing, one should sort of report back and say how it went.
Yeah. I mean, having materials, or at least ideas of what materials would have been really useful. The kind of structure would have been helpful, right? Planning such stuff. Because I can only believe that the skill of being able to read Mathlib at a reviewer level is going to become more important and not less important in the future. So figuring out ways to cultivate that, support that, spread that, I think is very important.
I mean, Andrew Yang has been trying to get into my head the fact that this is an important skill that we need to accelerate, turning people into reviewers. We had a long discussion recently. I mean, he's a young person that's sort of attempting to make his way in this, in this incredibly sort of chaotic area that we're in. So there's somehow a lot of uncertainty. But this is one of the things he was, trying to, sort of reminded me of, is that the community should be attempting to create more reviewers. And another thing he said, which I thought was quite interesting, was that he felt he had quite a good understanding of how lean worked. And he's written all this category theory with all this defect abuse that used to be allowed. And then Core changed it. And now category theory is going to have to do with, if we need to remove all this backward transparency stuff from the category theory files, where it was assumed by them that what they were doing was okay, and now it's been decreed by the core developers that it's not okay. And he was just like, what else are they going to decree? Exactly. What are the skills have I developed and techniques do I know how to use that are suddenly going to be removed from me? Which I thought was an interesting question. Because obviously he's written a huge amount of Mathlib, Andrew Yang. So non-trivial percentage.
Well, I think setting up systems to make it easy to do the right things, whatever the right things are decreed to be at the given time, make it a lot easier for people then. Uh-oh. Okay. Sorry, everything went blank for a second.
You're still there.
All right, good. Setting up automation, setting up tooling so that you generate, like what's being done with the infer instance as change, right? You just generate the right term formed correctly, rather than having to fight against.
Yeah, this is the thing. Core has the insights, so what's going badly. They somehow seem to see it before us. This is like Leo would always complain in Lean 3. Leo had complaints that Leo was just saying this thing is going to grind to a halt. We need to write Lean 4, and I was just like, well, it's working fine for me. And it was just at the very end of Lean 3's life that you began to see fast grinding to a halt. And we were like, oh, okay, this is kind of weird. What's going on here? And then there was the port, and it was like, oh, okay, now everything's fine again. But I think Core are very well aware of trying to keep the show on the road, and I'm absolutely certain the changes they make are for the best. But Andrew is just like, now we've just broken all this stuff. He's just like, yeah, but I bet Core's right. I bet their call is correct ultimately.
On that note, I do think the messaging could have been a little bit more positive.
Yeah, perhaps.
The isDefect change, about why it was being done and why it was in the interests of the Mathlib community to deal with it. And it came across a bit as, we've decided that what you're doing is aesthetically unpleasant and we're going to ban you from doing it because it pleases us to do so, rather than you need to make this change, otherwise your project is going to stop working. And yes, I can see Kevin's point that clearly there were good reasons for this, but I think it would have been better if they had been made much more known to the community at the time.
To be fair, though, I think there was a good deal of prompting from certain portions of Mathlib. The other Sebastian as one person who was on this issue about talking about the problems of handling the the implicit parameters, instance implicit parameters as default for transparency checks, and how it led to strange behavior. And this was something that had been on an issue that had been open for years, maybe.
Maybe about a year. Yeah, he had some genuine problem, right? He made some type synonym and then it didn't work.
And
they
so
were just
I can
like, yeah, that's
certainly,
what it's supposed to happen. He's like, wait a minute, though, I made a type synonym.
but I can certainly see from their perspective too, like, oh, there are people in the Mathlib community that were like, this is a problem, fix this kind of thing. And then they did. But, you know, Mathlib is not a homogeneous entity. There's, as we've seen in many discussions recently, there's people on the whole spectrum of opinions for different things. So, but yeah, communication is hard, I think.
I think one thing that,
indulgence about.
You see, I think one place, it's all right for me. You know, I'm in the maintainer chat, I'm in the reviewer chat. You know, I know what's going on first. And so sort of the senior people are all aware of what's happening. And then it sort of gets released to the community. And then there's a whole bunch of people going, well, I didn't know about this. And I'm thinking, how can you not know about this? I've known about this for weeks. It's like, oh yeah, I knew about this because I'm in, you know, I'm in with the in crowd. Like, what about all the people that aren't in with the in crowd? This is, you know, it's very easy for the people making big decisions to sort of not really notice that it's only the, you know, it's only a certain subset of the community that's being informed.
I mean, another instance of this is the change with the PR procedure, right? Moving from branches on the main repo to forks.
To make it like every other repo.
Yeah.
Yale was quite angry about that, I think. She's like, this breaks my workflow. We're just making it normal. So no. Like, why wasn't I discussed? You know, why wasn't this discussed?
But I mean, that was another thing that
we just
was considered and thought about for quite a while before it was implemented
by a small group of people.
Yeah. Well, I've noticed this is a decision-making procedure for a lot of people, and myself included, is where something just builds up, and then, you know, there's a snap decision, and then people start going. But that's not the healthiest thing to do, because everyone else doesn't notice all that pressure building up, and they don't experience the need. They don't experience the immediacy of the problem. They just see, oh, it's a breaking change, and it's being done fast, and there's not a lot of discussion going on. That's not good.
Can I just ask, just my own information? Did I understand correctly that the change in version 4.29 with how implicit parameters are resolved and so on was intended to fix, or at least to go towards fixing, the problem with type synonyms leaking that Sebastian?
That's my understanding.
I wish somebody had told me that 2 months ago.
Yeah. Yeah.
I'm cursing this change in version 4.29 for those entire period of 2 months, because it literally broke everything I was working on.
Yeah, we're still trying to fix FLT.
It's being fixed by it.
Yeah, you see, so again, there's another, you know, some lack of communication. But I was stunned by Guerzel's issue. It's like, wait, that doesn't work.
Yeah, it made for some, I don't think, you know, it certainly dragged on performance, and that's an important thing as the library grows. I think probably one of the most important things, but it also made for some very weird behavior in terms of your expectations about, oh, you can't access this instance, but in fact, if you try and access something that's projected off of it, now you can actually synthesize this. It's, you know, yeah, Cody asked for release notes that explain the change. And I think that's a good question, because I don't know where to point someone at to do that.
Words is fine. I just don't understand what the change was. What was this change?
So previously, if you had an argument inside of some declaration that was dependent on an instance, and you wanted to try and unify two things, you could, there's this control about how much do you actually look inside the definition to check whether two things are the same definitionally, right? If you're not allowed to unfold anything, you can't see past any name. You just like, oh, that's a different name, and the two names don't match, so we aren't the same. Sorry. But if you're allowed to unfold everything, you go all the way down to the nuts and bolts and you get these giant terms where you have to say, okay, this piece is the same, that piece is the same, that piece is the same. So it's a big drag on efficiency when you're trying to check. Okay, Sebastian is the expert voice here, and he has a link to release notes and language reference with highlights on this. That's excellent. Good. So I would follow that link to get the official detailed description. Oh, and actually, Tomas just put that one up in front of that. I need to learn how to read better. Excellent. Good. Good, good, good. No. All right. And we're running up onto the hour now. And I doubt anyone has showed up for the boot camp, so I want to ask again. Anything else people want to get off their chest before we close it out?
Oh, while I have the floor, I guess. What's up with CSLib? Like, what's the overlap? Are they a bunch of clowns that you've never heard about, or is there a high overlap, or something else?
No, it's a thing.
They're even more official than us because they're under leanprover.org, right? They have the stamp of officiality. But I think we're still trying to figure out what the dividing line is to a certain extent. But
There's
there's certain
kind
things.
of noisy people who you might learn to ignore. But
I ignore everything. I'm just curious about what the overlap is, because for sure what's going to happen is they're going to want to depend on a bunch of things in Mathlib, and now all of a sudden you guys are going to have the problem that they're going to care about what decisions you make.
I don't think they care about much in Mathlib though. They care about the bottom bit.
Yet at the moment, right?
At the moment, yeah.
There's some number theory things that are useful probably, and some combinatorics things. And I have to admit, I briefly considered I briefly considered doing some term stuff, and there's some term stuff in Mathlib. So now, yeah, I have to care about that.
Great. You should learn to care about math coding.
It's
good for the soul.
Let me tell you. My head is just too small for this stuff. There were some like really fiddly implementation decisions that were made for terms in Mathlib that are cool, but also I don't like. And so I'm just wondering how that interaction is going to go when someone braver than me decides to like bridge the gap.
You should try making a PR.
No. The decision
you don't use
AI is fine. It has to stay the way it is. I'm just wondering whether CSLib should break with this or adopt it.
Oh, let's go on #CSLib.
Yeah. I think there's still active discussion as to what the boundaries are between the two libraries, because the Mathlib has limited reviewing power as it is, and it's great if there's a whole other collection of energy and expertise that can focus on some of these parts, whether it's in Mathlib or whether it's in downstreamed something, whatever, up and down are hard, whether it's in the downstream repository or not. I think a lot of these decisions are things we haven't encountered yet, and so we'll have to see as we go forward what to do and sort of learn on a case-by-case basis.
All right. Thanks.
Or at least that's my official recorded answer for things like this. All right, so it's at the hour, as my cuckoo clock tells me. So we probably wrap up here. I appreciate everyone showing up. It's been good to chat about all these interesting things. I'm sure the next 2 months will be just as uneventful as the past 2 months have been. And so I'll see you back here, and I'll try and pull out more topics for us to discuss then. All right. Take care, everyone.
Yeah, thanks for chairing this meeting.
Yeah.